How's it going, everyone? Welcome, Eulero Gonzalez here, and today I'm going to explore now is the chapter 6, 7, and 8 from the book of You Don't Know JS Yet, Scope and Closures, as a way to truly understand is the reason why do we have models and why models are important to understand. So what is the utility from model? What is the value proposition of a model? So because just to make a quick recap of how do we get here. So in the chapter one, we look at the get started to understand now JavaScript from its conceptions. So who made that, the legal, who owns the legal trademarks, and also who oversee now the spec, which is the TC39 group, what this group is doing, what is the process of including any proposal to a particular spec or to be part of this spec. And that process is made of 5 steps to make a champion work or a proposal work all the way up all to the uh, proposal or to the spec, right? And because you can outrun JavaScript in different environments, the only reality that matters is the web. So you can run JavaScript on the browsers, or the server, the light bulbs, and even robots, but the web is the only things that matters. And because now the browser vendors actually have their own JavaScript implementations, so not all of them update that at the same pace, and they are not always uh, have the latest implementations uh, of the spec. So there is a time period of of understanding what the implementation says and what they need to do. So because of this, and if you want to use now these new features that are not available for in browsers, well, it turns out that there is something called polyfills that allow you to do this, right? And because now JavaScript is a multi-paradigm language that you can now run or create programs uh, in procedure or functional or object-oriented programming. We also look at how this machines works, right? And because this scripted language that works as an interpreter that goes and evaluate line after the another, this is not true for the current state of JavaScript, at least in JavaScript engines as it works. So because now it behaves much like a compiler, not in its output, but how it analyzes code. And because the concern about these JavaScript engines is that since they are now interpreted language, so they have to evaluate one after the another. In the case JavaScript, it's not purely that, but it turns out that there were some attempts back in 2013 by a bunch of engineers in Mozilla to say, hey, we can now run is Unreal engines by porting that code in using this ASM subset of JavaScript or ASM.js, which is a subset of JavaScript that is not meant to be authored by JavaScript developers, but just show that by passing is proper hints to the JavaScript engines to run some optimizations, well, you can now is run JavaScript engines, or you can run now games in these JavaScript engines. So years by, and then we have now WebAssembly. So WebAssembly say, hey, what if we skip now is the parsing phase, and we create this intermediate representation of the code that look like an assembly, and the output will be now a file that can be now run in any was environment. So now was becomes now a universal, portable target. So you can now have application in different programming language, Python, Rust, Ruby, and all the kind of stuff. And then now pour that into this WASP, and now whenever you have a WASP environment, you can run that. So this actually is not an attempt to replace JavaScript. It's just an attempt to now push things a little bit forward to say, hey, this is where we need to be. The software needs to be as close to the machines. We need to make things as fast as possible because in this competitive landscape, when you're building applications, so for example, for consumer applications, perhaps that not might be sometimes quite sensitive. But if you're building now for military grade or financial or airspace or any other critical industry, so well, now speed becomes a critical factor. So because now JavaScript, as it evolved from 1993 to this day, and back then we wouldn't have a lot of the things that we have now, and one of them is to avoid some common errors, okay, and now have a better chance to the code we write. JavaScript can optimize, it can further run optimizations and make the code run faster. So this is what UseString is doing. So this is just the first step, right? The first page of the first introduction of the JavaScript, something that are around the JavaScript. It's not purely the technical aspect. And then we look at the more technical aspect, that what a program is, how now JavaScript make all of these different how JavaScript see a program, how now JavaScript make all of these different programs to cooperate at runtime. So what are the values in a program? Why we care about values? So we have primitive and objects, because values at the end of the day represent is the state of that program. And by looking at the primitive and the object, and especially the object, whether it's like a hash or in a collections or a function, right? So now when you explore about functions and how you can define your functions and how you can use your functions, whether it is as a function definition or a function declaration, a function expression or a function declarations, this particular concept of hell now is a function as a value is something that enables you to develop application in the functional patterning way. Why this is important? Because if your applications require computation, right, there is now a particularly pattern in software engineering that say, hey, functional programming, and it is patterns arise that high order functions, currying pure functions, all of those are useful for writing maintainable and easy to debug code, right? So I also explore when you're working with values, right? So how you compare values, how now JavaScript compare different type of values or the same type of values, right? What is now is this equality reference, which is true for primitive and objects, and how now the comparison happens in objects, right? And also is, well, when you have now is one value that you want to convert to another, what is the operation that happened? What is the abstract operation that is going on, and how it works, right? So what happened when you try to transform from a number to a string, from a string to a number, from a boolean to a number, from an object to a boolean, an object to a number, an object to a string, right? And also is, well, as we know how to use values to hold the state of a program, then how can we write our programs in a way that is easy to understand? So to organize our programs, whether it's a function or whether it's a class or whether it's as a model, right? And also a little bit of the root of JavaScript, at least in 2021, okay, which is how you can now iterate through a sequence of elements, and why do we need to understand the iterator or the iterator and the iterables, okay? Why that is useful, and also is the anatomy of a function, whether it is via scope or closures, as well as the value of this, and also understand the anatomy of the objects, how you can now is delegate property access via the prototype change. So all of this is just to summarize is this in 10 minutes, in less than 12 minutes, all right? This huge overview about it. And I think that if you're able to generally describe that, you will understand a lot of the time what you are going to do in your programs. So in the book, in the second book here of the scope and closure, which is actually getting to the root of this anatomy of the functions, right? And this is not exclusively to functions, but also to block or any place when you need to define is the visibility of certain variables. So because working with variables and with values is one of the most important things that you need to do as a programmer. And in the case of JavaScript, since you can define your variables inside of this block or functions, and the way how they relate it is by following is the scope rules, which are not modified by runtime conditions. So because we can held now functions inside of we can define function, and inside of the functions define variables that can be held as a variable. So that scope, which is determined before the code is executed, is now creating is a place where all of these different identifier of the variables now are scope, aka creating is now a closure for to access variables that are outside of a function. But the point of this is this, and because of that, well, we briefly went through the understand the classic compiler theory, why this is important, because now JavaScript doesn't behave like a interpreted language. It behaves pretty much like a compiler one, as I mentioned before, not the way of how it returns code, it is output, but most likely of how it analyzes codes. So because of that, we look at the three common phases of the compiler, which is tokenization or lexing is going to take all of these different characters and then transform that into meaningful tokens for the language, right? So pretty much when you read text in English or Spanish or in any other language that you are quite familiar, that's what you are looking for. That is exactly what tokenizer is doing. And the lexing, it means that if this particular image changes, the tokenizer, how is going to now differentiate one token from another, right? The other is once you have all of these strings of tokens, so the parser here say, hey, let us now is create is this relationship with all of these different tokens, all right? And by constructing now this relationship in a tree-like data structure, so we have now the abstract syntax tree. And then finally, some compilers might output or generate the code that is be run on that particular platform, right? So you can now have a portable binary output that can be run in any platform that was the code was compiled. So whether it is on an iOS or a Windows or a Linux distro, specific Linux distro, or even an Android or iOS or Windows phones, you know. But in the case of understanding this is because now JavaScript, when you look at how it behaves, especially when detect early errors, syntax errors, and hosting, it behaves much like a compiler language rather than an interpreted one. Because when you have this kind of errors, it runs this first, or it make this compiling phase before the code is executed. So as a way to also understand now how you can assign is variables, right? Because all of this, the whole premise, the whole point of describing this is to understand now how hosting works, all right? And in order to understand how hosting works, we need to look at how you can assign values in variables. And bear with me. So in variables, you have now the left-hand side and the right-hand side. So this is just a way of how you can now identify is the terms in this equation, all right? At least in the computing sense. So because you have is now the source or the target of this assignment, right? And the source is something that it comes from, all right? Unlike the target that is now the identifier that is going to be assigned this value, all right? It seems that on the lexical topics, which means that when you define your code, that is when that particular identifier or variable that hold it is value, it'll be defined, it'll live. You can also is modify is the runtime conditions. Using is the eval. Something that you shouldn't do it. It's important at least to understand that. And then when I go into the another or to now understand is, well, how is that JavaScript? What is the analogy or the what is the analogy or the illustration here? Right? So how you can now think about it? What is the illustration of this lexical scope of how the things actually works? So you can think something. This is by Kyle Simpson, right? So Kyle Simpson actually describes is like having a conversation. So on the first phase, on the compile phase, is that the scope manager have a conversation with the compiler, right? Where it's going to now identify all of this. Well, it's going to recur all of these identifiers, all right? And then on the execution, the scope manager will have a conversation with the engine, right? Where now is when it's going to assign the value to this identifier. And if its identifier doesn't exist, well, it's going to now throw you an error. So this list of identifiers, right, that now they're going to live in a particular scope. So this scope, whether it's a block scope or a function code scope, or also they catch in the try-catch block. But before 2015, a lot of the time, though, that scope it was created is by the function, right? And in other programming language, you can create a scope by using the curly braces, right? But in JavaScript, we didn't have that until the ES6, where now we can create is scope, block scopes, and the way how this actually works is by whether you define a block or a function scope and you define identifiers, aka variables inside of this scope. Now what it's doing is creating on each one of those scope a reference to the outer scope until it reached to the global scope. And when you hit the global scope, well, the global scope doesn't have, so the reference to the outer scope of that global scope is null. So you hit the end of the row. Good. So I mentioned this, all right, because as we explore now the concept of the scope chain, which you can think of this like an elevator, like a building, right? When the more nested block scope or scope you define, is like you are now increasing the height of your building, right? And all of the different level that it needs to go to find that out is that identifier in that scope. So I mentioned this, all right? It's just to now get into the weeds to look at the function and the block, and now how the functions and block scope behave when you define functions that inside of the variables. So vard actually are scoped by functions, were not as block, and let and cons are blocked by scope, the curly braces. So understand this, and also that you can have different other type of a scope. For example, on the parameter scope, in that anytime that you define a function and you assign that to a variable, it is important for us to define that as a function named parameter. Why is that? Because you can now lexically access to that function, and second, you describe the functionality of this function. So all of this is just to at least look at this particular scope, the function and the block, and also the other scope, the global scope. And the TLDR of this scope is that those act as a place to share now functionality amongst nested scope. So because here in the global scope, so for example, like the browser, where you can now have is variables and functions. So they have a particular behavior here. So the variables and functions, they're gonna be attached to the window objects. And the window object allows you to have access to the DOM elements. This is when we're starting to now shift our attentions to the dynamic of the language, to now understand is how the engines or how the browser engines works, right? AKA how now you can look at the particular page, to be more explicit, is that how now the browser transforms HTML, CSS, and JavaScript into pixels on the screen. Okay, this is known as the critical rendering path. So I know that is a lot, but bear with me, because here we're making is a quick recap of this and finally get into what we really get into this video. So this is now the window object. all right, or the global scope. And we also now have another scopes or another global objects, another place where we can run now JavaScript. So for example is the service worker. So here you don't have any window objects. You have now the self objects. That the benefit of using service worker is that if you need to put aside some computations without blocking the main UI, so this is the place where you can create this, or you can put all of this works. And also you can, for var and function actually is going to be attached to the self objects. Let and comes, they don't attach those identifiers to the global object, pretty much like the global object. Another is the model scope. So where the model scope, for example, like ES6 or CommonJS, so they behave now like if you are using a function and wrap that and passing some specific parameters, right, that you can have access to. In the case of the CommonJS, like the dir name, the model, and so on and so forth. So if you define var or functions, because there is no global object here, there will be now scope into that particularly model, whether it's a CommonJS or ES6. So with that huge overview of the scope and the global scope and why do we care about the global scope, we then now shift our attention to understand is the intrinsicies of how now this identifier or these variables, whether it's the let, var, and const, behave in each of these particular scope, whether it is the function or the block, as well as the looping iterators. So here is when we look at, well, now functions and var are hosted at the top of that scope. And that scope, whether it is the global scope or the function scope, in the case of the let and const, they are only scope, so their scope are now on the block scope. So var scope doesn't work in there. And also is a justification of why now functions and var actually is a scoping, right? So it turns out that the first portion of your code, again, this is based on the observable behaviors. So you want to define is the first portion of your code of the executable code and then the definition. So this will makes much more sense if you are having a huge functions that inside of that has a lot of functionality that needs to be run in that particular scope. So this is the reason behind why we have now function scope and closures. And the other is with var, right? So you can use this as a place where to store or pass now data when you see fit. So because the reason of why of having now let and const, and especially with var, because you can redefine that identifier and reassign that variables. So this was problematic, especially if you want to maintain your applications. This is what the TC39 say, hey, you know what? Let's go with let and const. And it makes a lot of sense with const. Any identifier that use that, hey, you can redefine or reassign that later on in the code. And in the case of the let, well, you can reassign the value, but you can't redeclare that. But to me, it's not that clear that why they, because with var, they host, so they put at the top of the scope. To me, it was not clear that why they didn't put let as this particular behavior that var has. So why they don't put now at the top of the let or the block scope? It makes more sense to say, hey, no, with cons we don't want to do that, but why don't say that let? Well, it turns out that if cons is this way, so now let is the same, so bundle up and close the theater. So yes, this is why, for example, with let we have things like TDC, the temporal dead sum, which is the place of when you define now a variable with let, and you try to have access to identify before its definitions. This is something that known as a temporal dead zone. Hey, that identifier is not defined here, and this is not exclusively to let. This is also true for any variables that is defined before, or that you're trying to have access before you define them, right? So we can also look at the var as well as an example. So and then how now is the let and cons behave in this looping iteration, or how let and cons behave in this looping syntax, whether it's for in or for off, all right, or even in a while, and particularly the for, as it is, the plain old for, the good old trusty for, all right. So because this is also a particular challenge with a lot of the people actually use that. See if you know how to work with block and scope, and exactly, if you know how to work with the scope and how you can schedule now tasks to the micro task using now the set timeout as well, just to see if you're able to understand now this intrinsic nature of the language, which is how you can use now a scope in an iterating loop and schedule those tasks to the web internals API. So all of this, right, is just a way of to put a test people out there to see if they truly know what they're doing, because we need to know, if you have a company, you have to know, you need to hire people that actually are good at what they do and understand and be able to describe this in the most succinct, precise way possible. So after that, right, and now again we shift our attentions to a more right, so we shift our attentions to a more sorry so I shift my attentions to a more high level, to a more high level. So I shift my attention to a more high level thinking. So now that we know the intrinsicies and the mechanism of how to work with scope and variables, all right, now we rise our attentions to a more high level thinking, which is what are the decisions and patterns applies across our programs. This is now a progression, okay? This is something that, and I really love about, and I want to make a quick pause here, is that if you want to go from point A to point B, you don't do that by following prescriptions. You don't do that by following steps of somebody else. No, you just start from where you are. And in my case, that's actually what worked for me. I start from not knowing, not even be able to describe English, not even to talk about English in this way, to not knowing what in the French toast what happened in JavaScript, all right, to actually describe all of this and weave this story so I can now describe it in the most elegant and eloquently place. So I can describe it in the most elegant and eloquently way, not to convince you, but also is to understand that what I know is this particular way. So this is my train of thoughts, and wow, this is something that so not only the technical aspect, if you are in the engineering field, is something important. Is that, hey, you know how these things works, but also is that how you're able to describe things. So your storytelling, and oh my God, this is what I and again, not to. And I'm not doing this is to trying to convince somebody else. I'm right now recording these videos is because I want this to, well, understand all of this, and if I need to explain that to somebody else, I know what will be the train of thought. That's all. That's all. So now, right? So now that we know how scopes and working with variables actually works, okay, the fundamentals. Now we have that fundamentals firmly in place. So we rise our attention to a more high level thinking, which is the decisions and the patterns that we need to apply to our programs. And that is when we have now the least exposure here. So this is a concept from software engineering that, especially for security as a defensive strategy, to say, hey, let's make our programs, so let's going to prevent, or let's going to increase the security in our applications by following is the principle of least privilege, aka, so if a user wants to have access to this, I'm gonna give it the bare minimal amount of rights to have access to. So, because the overall architecture, and this is now go more again, so we shift now our attentions to this high level thinking. So what are the decisions and patterns that we need to know to organize our code, or that we can apply across our program? Okay, so if you have now different models, right? In each one of those models, the way how you can make them resilient across a particular attack is by only expose them and make their capabilities is to only attach the relevant and bare minimum capability to that. So if an attacker wants to access to a particular model or a particular area in your program or in your architecture, it'll make it much more difficult to go to one place to another, right? So you are now reducing the overall system, so you're reducing to compromise the overall system, right? So this architecture here that allow us is to have this defensive way that I think that has been a losing strategy because now encryption has become way much more effective in terms of protect data, right? But in any case, here the idea of this is that when you apply these particular patterns, these decisions and patterns in our whole programs, now by avoiding to expose them or by avoiding to overexpose variables in our programs, When you do that, you avoid an entire classes of boxes that might appear. So for example, is the name collision that happen in the global scope. The other is the unintended dependencies. So when you are exposing too much information to the outside world, uh, whoever is going to consume that is also needs to also is carry over those things as well. And the other is the unexpected behavior, because if you expose things and they are not used in the proper way, now your application might behave in a way that doesn't supposed to. So the idea of this particular chapter is by looking at how you can now minimize is the overall exposure of your application, the overall overexposure of variables in your programs, uh, is by now not only looking at the immediately invoked function expressions, uh, but also is not only that, by looking at the immediately invoked function expressions, but also is that how you can now encapsulate is uh, data and its functionality in this particular scope. So if people wants to have access to that, or other author needs to have access to that, they will they will you are now hiding is this details, or you are hiding is the private details to this. So this data abstractions or hiding the informations and only exposing is the functionality as an API via the functions is a lot of the time how you can now is eliminate this kind of bugs, right? So this is what all of this is describing here, all right? So when you use now, whether it's an immediately invoked function expression, and then you assign that to a variable, so you know that that immediately invoked function expression that exposes certain functionalities, okay? So when you assign that to a identifier, a variables, if you want to have access to the information, you wouldn't have that at once. You only have that by the functionality that the author of that functions exposed to you. So this hiding private details is one of the things that as you develop applications and so on and so forth, it started to develop these notions of security that is involved. Oh my god, that makes a lot of sense. That makes a lot of French toast sense, bro. Right? So whether it's your scoping is with a function or with a block, right? The whole point of using is this scope is to now hide some private details and only expose is the relevant API, the relevant data and functionality that you want to. That makes a lot of sense to do so. That makes a lot of sense to do so. The question is that when to use now var and let. It is a matter of taste. It is a matter of choice when to do that. All right. And even catch is allow you to have now this another do thing. So once we explore this particularly scope here, right? That whether it's a block or a function, trying to define is now functions declarations in block or functions definitions, exactly functions declarations in a block. You want to avoid this. Why is this? Because it will be very hard for you to debug this kind of stuff. And the idea of this is that, for example, for polyfills, when you need to define is when you need to check if conditions, right? this is a lot of the time you're gonna, well, use now an if. But to avoid this unexpected behaviors that might happen when you have now function definitions or not, all right, especially so you're not trip around what this function is going to do when you do this kind of stuff, all right, to avoid trip you up, it is better to hold now that functionality into a function, all right, and if that functionality does not exist, then now reassign that functionality to, or define the new functionality to that, which is in this case not like this, all right, not like this, but it's defining now the functionality and held that as if as an identifier, right? And then is when you're gonna check that. Hey, if that now is if the functionality exists, so override the definition if you must, right? Type of array is array, all right? If it's not, this is great for using now the polyfills or for feature that hasn't been implemented, not only to the language but also for your code, all right? So things that haven't been implemented, here you say, hey, this is the functionality that I want to implement. Let me check first if I have that by default. If I don't have, then let me now is assign that. So now that I look at that, right, and as we explore is this high-level thinking, what are the decision and paths we need to apply to our code? Another is the closure, which is the way how now we organize. So the closure is affect how now we organize variables in our programs. Okay, so up to this point we have focused the ins and outs of lexical scope. Okay, so how to work with variables, how to work with scope, and now this high-level thinking of, well, what are the patterns and the decisions that we need to apply to our program as a whole, all right, that affect how our programs are organized. Okay, the scope and variables or the lexical scope affects how our scope or how our programs are organized. So again, our attention again shift broader in abstractions to the historical, somewhat daunting topic of closures. And this is because anytime that a programming language now can hold variables, or can hold functions as a variables, aka when the functions is when any programming language that functions are values, you can use now a closure. And not only closures, it allows you to unlock is the functional programming patterns and decisions to apply across our programs. And this, it makes a lot of sense. So again, we are only focused, our attention is on the functional programming or functional scope here, but then we can also is focus our attention is to the object and classes as well. So for example, which is another part of the book, right? We're here, we're going to now explore is this topic. The object fundamentals, object as a containers, and all of these kind of stuff. So how object works, okay? And classy objects, and the this work, and the delegation pattern, and so on and so forth, right? So yeah, so that makes a lot of sense. And then after that, we're gonna look at the types and grammar. Okay, something that I also quite familiar with this. So for example, with the primitive types, and then the primitive behaviors, and then the object values, and the coercive values, right? And I think they also put it now that, which is the EX next beyond, they leave that as it is, but also is the asynchronous nature of the language, which is something that they don't explain that much here. So for example, like promise or generators and async and await, and async and await. And yes, but again, uh, back to what we care here, okay, which is this. So now things started to make a lot of sense here, uh, in why we need to understand is the scope and closure. Why it is important for us to understand is the fundamentals, because or in any problem that you have, okay, uh, nature has hidden the solution is not in its, not in the solution in itself, but in the problem in itself. In other words, to understand what the problem is, go into this, and in this case, well, this is not something that is so wild because this was defined by the humans, but for things that are outside in the outside world, all right, how things work, and also only by observation. This is it. So in any case, so using closures, here we are. So our attention again shift broader in abstractions to the historically somewhat daunting topic of closure. And I don't see this as a daunting on topic like that, um, because closure is the natural step in the evolution of your understanding when you now understand how the lexical scope works, the ins and outs of the lexical scope, why it is important for us to uh, uh, raise our level of abstraction, of level of thinking, to know what are the patterns and the decisions that we need to apply to our programs. So for example, is the principle of least exposure to encapsulate now is the functionality of our codes, and only expose is the data that is relevant to the outside world. By hiding is the detail here. And because we're talking now scope and closure in scope, so functions allow also is to now is holding variables from the outer scope in the inner scope, and because this scope structure is defining before the code is executed, all right, now this won't be altered by runtime conditions, and this scope structures is now going to be there anytime that you call that function in any different part of your program. So this is what a closure is. So you are holding a reference of the identifiers or variables that live outside of the function, and now run that functions in any different part of your programs, and keep that reference or remember that reference from the outer scope even after the function was executed elsewhere. So I do think that this is very powerful concept, because now when you do this kind of stuff, you can now remember things. All right. So any time that you need to remember things, you can now wrap a functions and make use of that variable outside of the function. All right. And if you want to update that variable, all right, you can do that, and well, it will be so you will now have a reference to these variables. So because you are holding is a reference to these variables, okay. So this is not garbage collected by the garbage collector, all right, or this particular program that lives in certain high-level programs that allow us to not worry about when we need to freeze memory. uh, is this particular program that take care for us. But those reference or those identifiers only going to be electable by the garbage collector when you now freeze up that memory, aka by creating is now a function, or in this case, um, the way of how now exactly. So those references are a live link, not a snapshot. All right. And for example, here you are closing over the I, all right? And anytime that you call now here, what you're doing is, hey, let me now is add this reference value here, all right? And it going to now hold is 3 because this is now block function, all right? And you are holding now a reference to this. Because here it's going to execute this, and since you are now holding is a reference to the outer, exactly. Look at this, you're holding is a reference to a variable here that is going to be updated. Exactly. Your holding is a reference here. Your holding is a live reference here to these variables, not a snapshot, which is happening here. Okay? Not a snapshot here. So this kind of closure illustration typically use a set timeout or some other callback like an event handler inside the loop. I'll simplify the example by storing functions referring in an array so that we don't need to consider asynchronous timing in our analysis. The closure principle is the same regardless. So, but in any case, this is now by exploring the closure, see the closure's behaviors. So closure is originally a mathematical concept from lambda calculus, but I'm not going to list out of the math formula or use a bunch of notation and jargon to define it. Instead, I'm going to focus on practical perspective. We'll start by defining closures in terms of what we can observe in different behavior in our program, as opposed to if closure was not present in JavaScript. However, later in this chapter, we're going to flip closure around to look at it from an alternative perspective. So closure is the behavior of functions and only functions, something that I know and how to do. And how you can create now is this closure. So you can create is now, this closure is by wrapping a function and inside of that have the use outside variables as a reference like live snapshots, and then when you call that function, you're going to hold that here. So here, that's what it's doing here by holding those reference outside of this. It is a live snapshot, okay? It makes a lot of sense to hold that kind of data and variables as it is. So common closure in Ajax and event. Closure is the most commonly encountered with callbacks. For example, like this. All right. Functions look up student record, student ID. Exactly. Common closure is found in Ajax and events. And it's important also is that find a way to remove any reference to the closure. Okay. And this is the observable definition. Closure is observed when a function use variable from the outer scope even while the function is executed in a different place, or even exactly. Even if that function is executing uh, in a different place where those variables wouldn't be accessible. So the key part of this definition is that a function must be invoked, a function must have a reference of the outer of a variable from the outer scope, and this function must be invoked in a different scope changed from the variable. Mm-hmm. And this observation oriented definition means that we shouldn't miss closure as some indirect academic trivia. Instead, we should look at plans for the direct, concrete effect of closure have on our program's behavior, which is the closure lifecycle and the garbage collector. Hey, you need to find ways that when you want to create now a closure, which must be um, must be invoked by a function, and that function must have a reference to the variable on the outside. Um, and that reference must, and that variables must have a reference from the outer scope, and that function invocation must happen is in a different branch for where the variable in a different branch of the scope changed from the variable. Makes a lot of sense. So this is the closure lifecycle and garbage collections here. Since closure is inherently tied to a function instance, okay, it is closed over a variable lasts as long as there is still a reference to that function. So if that function still have now a reference to that variable, uh, and if you define 10 of those closures and you get rid of 9, that last one will remain and will be preserved. So the garbage collector wouldn't be able to, to discard that, to freeze the space in memory for. This is why that anytime that you create a closure, you also find a way to remove that closure. Mm-hmm. And another question is this: hey, if this is per variable or per scope, right? Uh, Conceptually, closure is per variables rather than per scope. Ajax callbacks, event handlers, and other forms of functions closures are typically assumed to close over only what they explicitly reference. But the reality is more complicated than that. Another program to consider when you have is this is here, right? The reality is that because you can modify is the scope of that. You can also alter is the closure of that. Something that you shouldn't do that, but you know that it is. You may wonder how you can modify the scope of that. Well, by looking at the eval as it is. Mm-hmm. So we are not removing a student record from the closure scope that we cannot control. And we are ensuring that if the student records remain in the closed scope, the variable is no longer referencing the potential large array of data. The arrays can be garbage collector. Again, in many cases, JavaScript might automatically optimize the program to the same effect. But it's still a good habit to be careful and explicit, make sure we don't keep any significant amount of device memory tied up any longer than necessary. And this is an alternative perspective, and I'm gonna read that while I am eating. All right, fellas. Increíblemente bueno. Esto es más pepa que. Okay. Esto fue más pepa que otra verga, mano. Fue más pepa que otra verga. Lo que Juan no sabría es que ese octubre de ese año sería uno de los más alocados y sería uno de los más alocados y vomitivos. Podría existir. De la mano de Sevin. 7. French. French. New de Sevin. Yeah. And we are back, right? Maybe with a different outfit, right? But I want to actually is now dive deep into the closure as a way to close over, no pun intended, the entire history of JavaScript, the technical aspect of JavaScript, as well as the things that are around JavaScript, the social aspect of it, and also the intrinsics in terms of the scope and closures, and how now by understanding the ins and outs of lexical scope, which is uh, how you why working with variables is so important, why here we look at that, especially because when you now when the language like JavaScript give you is a JavaScript language, all right? Yeah, so um, when JavaScript, when language like JavaScript now make functions as a value, so it open up now the functional approach and all of the patterns that allow and they come with it, which is well, use those functions as variables, and because now functions you can define is variable inside of that, similar like block, and each one of them follow certain rules defined by the scope variables. So how they relate functions and block is determined by the scope rules, and because those scope rules are not modified by runtime conditions, you can do that, but it's not wise to go with. But usually, when you don't actively modify the runtime conditions, it stays the same. So when you assign that functions and all of these variables that might have reference to the outer scope, all of this structure, aka the scope structure, is actually maintained, aka a closure. So we looked at now how JavaScript behaves more like a compiled language rather than an interpreted, in terms of how it analyzes the code, not how it generated. And the lexical here is because JavaScript now in the classic compiler theory, so you have now three phases, which is the compiler or the tokenizer or the lexing, where it convert all of these strings of characters into meaningful tokens for the language, and then it's going to see the relationship of each one of those tokens, known as the parsing, by creating this abstract syntax tree, and then usually it generates the binary code for that specific platform. So in the case of JavaScript, we look at the lexical scope, all right? And now how, for example, when you define this scope and inside of that more nested scope, the relationship among them, not only that is defined by the scope rule, but also you can have access to outer variables lexically via the scope change. So that's great because now that we understand is the scope change and the lexical scope, and also we explore these other different scope that we have in JavaScript, for example, like functions and blocks, and also inside of the parameter of a function, the global scope, and the different places that we can have our global scope, whether it's on the browser with the window and have an access via the window objects, how now the variables behave in this specific context, whether it's var, let, and cons, whether it's on the function, on the block, also in the global scope, like the window, the service worker, as well as the models in Node, whether it's CommonJS or ES model. And what is the goal of the scope, which allow us to share now functionality across different scopes, right? And then look at now how can we or so understand the different the behavior of variables in different scope, whether it's in function scope, in block scope, also how var and functions, let, and cons behave in each one of them, as well as the looping iterations or the looping syntax. So for of, for in, while, and for, the traditional for. And as we explore also is this particular nuance that have let and cons, known as the temporal dead zone. A lot of the time, we want is to avoid that, and this is not exclusively also for let. It is also for var as well. And what is the specific behaviors that var and function have, known as hosting, all right? And as we explore how that behave and the difference between the let and cons, we also now shift our attentions to a high level thinking, the decisions and the patterns that we need to apply across our programs, which is more about organizing our code with this particular principle known as the least exposure. That follow is the principle of least privilege, where the idea is that if you have now a system with different components and you want to make them robust, okay, so you're only going to connect with the bare minimum capability needed. So if an attacker or a component misbehave, it will alter the overall system. So this is more like a architectural decisions, okay, that a lot of those patterns now are embodied into these frameworks. So now it's it's not a thing of when to implement those patterns, but more like what cloud service do I use, right? So again, this go beyond the scope of today's video, but what is relevant is that when you now follow this in your code, these decisions and pattern in your code of limiting the overexposing of variables, so you can eliminate an entire classes of bugs. So for example is name collisions or the unexpected behavior. So if some of your consumer now using that variable in an unexpected way, and if you reduce the surface area, so a lot of the times that actually is less likely to happen. Similar to unintended dependency. So when you need to refactor your code, it make much more easy to do so. So the previous or the unexpected behavior now it is solved by with TypeScript, and the unintended dependency is now solved by versioning your code, right? So also we look at how useful now is using is immediately invoke function expressions to go with, all right? So to encapsulate all of that functionality, and it is data there, okay? And then you attach that the IIFE to a variables, and only when you want to have access to those data or the data inside of that, you only gonna do that based on what the author allowed you to do. So this is part of the security of our programs, okay? And I think that's very, very interesting and relevant, all right? So you don't expose yourself to some critical aspect in libraries or frameworks out there actually is going to expose the bare minimum, despite that it might be open source, all right? But despite that, the author of the code is going to expose now certain functionality to the outer world, and any private detail or hidden informations are kept inside of that scope of that immediately invoked function expressions. Also, we look at why it's not useful to define functions in block. All right, because you're gonna have some unexpected behavior, so it is preferred to now check. So the common use case for this is when we need to check if if a functionality exists. So if we have that built-in functionality, okay, whether it's on the browser or the node environments or even in your own code. Hey, if this functionality exists, if this exists, good. If it's not, let me now define that here. So now, after that, so we shift our attentions to a some daunting topic, but relevant, because at the end of the day, all of this talk start by exploring is the scope and closure, but it's by looking at functions and how they behave in the language, and what are the things that allow us to do. So one of them is closures. So closures is a natural okay. So closure is one of the ability that function have when they can be held as a value in variable. So closure at the end of the day, all right, is allowing us allowing a functions to have access variables that live outside of the function even after this function is executed in a different branch of in a different branch scope where the variable was defined. Okay, so we look first at the observable behaviors, and that's interesting. That's interesting. This is also why, and here we are not reinventing the wheel. I look at this as that here we are not reinventing the wheel. We are just uh, expose ourselves to the functional paradigms, and there is a very interesting book also written by Kyle Simpson. Okay, like this. So if you take a look at I do think is this exactly. Why functional programming at a glance, confident communication, readability, perspective, how to find balance, and the nature of function. So this functional like JavaScript is all around, and also it draw here the lambda functions, but it's all around now functions and the behavior of functions in programs where that is a value, where you can use those as values. This is the reason of using that. And why is important? Well, because when you need computation, okay, well, yeah, exactly. So when you need computation, uh, functional programming is an approach to this problem to guarantee the maintainability and the readability, oh my god, the maintainability and readability of the code, right? So while guarantee you have a performant code. So this is okay, I get this story here. I totally get it. I totally get it. Okay. Okay. Good. 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 All right. So this is closure. All right. So anytime that you need to keep track of some sort of information, uh, in that and hold that reference as a live it is not as it's not a snapshot. It hold the live reference. It's a live link. Okay. When you need to hold that, when you need to remember some sort of informations, uh, over time, you might want to use now closure. So the closure, the observable behavior of closure is that you need to define a function, which is this. You must invoke the function, and that function, you must define is a function, and that function must be invoked. Exactly. So you define a function, and that function must be invoked and hold a reference, and hold a variable reference from the outer scope, and that function invocation must be due in a different branch of the variable scope change, or of the scope change from the variable. Okay. So this is the observation-oriented definition. That means we shouldn't dismiss a closure as some indirect and academic trivia. Instead, we should look at plan for the direct, concrete effects closure have on our program's behavior. So the closure lifecycle and garbage collector. So again, this is the observable behavior, but also it has some implicit behavior, which is if you continue to keep reference of those variables, even when you execute that functions at a different scope change from the variable, the garbage collector won't be able to do its job. So it is safe for us to not only when you define is a function. Okay, that makes a lot of sense. When you want to remember a data, a piece of information, also you need to find ways to remove that piece of information, define some logic to clean up that. So for example here, all right, remember that a closure is when you define a function, and that function you invoke that later on, and hold some reference that leave outside, in this case callback, that leave outside of the function scope, and that will be executed, and that function will be executed at a different branch, aka it will not be executed here, it will be executed at a different for example manage button here, it will be executed at a different scope change from the variable. Okay, it will if that is the case, so we need to somehow define here some sort of logic to clean that up. All right, and in this case passing no callback to unsubscribe all click handlers. So for let handler or click handlers, the button that remove event listener, you have the click and the handler. And follow here the click handler as it is. So alright, so it makes a lot of sense. It makes a lot of sense to do so. So when you don't pass any function like this, when you don't pass any callback here, so what it's gonna do is to remove all of the event listener as well as the handler as it is. So it's freezing the memory, and making that available for the garbage collector. And the question is that, hey, is this per variable or per scope? Well, conceptually, closures is per variable rather than per scope. Ajax callbacks and event handlers and all other forms of functions closures are typically assumed to close over only what they explicitly reference. But the reality is more complicated than that. Another problem to consider, function manage student grades. For example, here, return add grades. You have the function get grades, and function sort and trim grade list, and function add grades. All right. So well, it is mentioned here that what will happen, what will close over here. So here we are now closing over to the add grade. No, we are closing, so add grade is a function that is closing over to grades, as well as the sort and trim grade list. Right? In fact, exactly. So because this will be now executed at a different branch, for example, like this, right? It will hold now those variables, the grades, sort and sort trim grade list, outside of that scope. So AKA, it will hold reference for those identifier. So consider the get grade variable, and it is a function. It is closed over. It is referenced in the outer scope of manage student grades in the .map get grade call, but it's not referenced in add grade or sort and trim grade list, right? In this case, no. What about the potentially large list of a student record, for example, like this? Exactly. What about the potentially large looking here? So if now student record is huge, so now that functions, when it's called, it's going to hold, and it's going to reserve a space in memory for that list, whether regardless it is size, okay. And then it's going to now return the add grade, right? So the second inner function is here. What about the potentially large list of a student record we pass in the student records? Is that variable close over? If it is, the array of a student record is never getting garbage collected, which leads to this program hold onto larger amount of memory. But if we look at closely again, none of the inner functions reference of the student record. According to the per variable definition of closure, since get grade and student records are not referenced by the inner functions, they are not closed over. They should be freely available for garbage collected right after the manage student grade call completes. Exactly. So for example, the get grade and student record are, since get grades and student records, for example here, since get grade and the student records are not referencing, uh, here exactly, since get grade and student records are not referencing by inner functions like this, so they should be freely available by the for garbage collector right after the managed student call completes. Indeed, try to debug this code in a recent JavaScript engine like V8 in Chrome, placing a breakpoint inside of the add grade function. And you may notice that the inspector does not list the student record variable. And that's a proof that debugging wise anyway. Okay, that's a proof. Debugging wise anyway, that the engine does not maintain student record via closure. Phew. Okay. But again, it's because closures are per variable. Closures are per variable. And because we're not maintaining any reference, inner reference of the student record in any of these functions. Okay. So it is now garbage collected to that. But how reliable is this observation as proof? Consider this rather contribute programs. So let's say you want to now is modify is the runtime conditions. So if you of course modify the runtime conditions as it is, all right. So for example, when you call now this with the info and the name and the grade, this allows you to now fetch that data here, and dynamically, exactly, using eval is a bad idea. But the thing here is that you can now change the scopes, is a scope structure at runtime. You shouldn't do that, but you can. So the language allows you to do this. So all the variables were defined would definitely preserve via closure, like this, like the exactly. So for example here, all of these variables are preserved via closure. Again, closures are per variables, per identifiers, right? Closures are per identifier. That makes a lot of sense. Notice that the inner function getInfo is not explicitly close over any of the ID, name, or grade variables, and yet calls to info seems to still be able to access the variables, albeit though use of the eval lexical scope cheat. But again, here we can now have access, even though, okay, this is interesting. Holy fuck. Even though that we are not explicitly indicating what variables can we, what variables reference inside of the function we want to use, we're doing that dynamically, and then you can have access to those. So all of the variables were definitely preserved via closure despite not being explicitly referenced by the inner function. So does that disprove the per variable assertion in favor of per scope? Depends. Many modern JavaScript engines do apply an optimization that remove any variables from closure scope that aren't explicitly referenced. So if I do this, and again, this is not, the console is not a true JavaScript engine, all right? Okay. It's because, well, any fire any Chromium implementation actually are scared to death. Eval error. Call to eval block by CSP. mm-hmm. Okay, so Chrome and Firefox actually say, hey, do you have any eval here? Forget about it. No. Okay, okay. So browser doesn't allow you to run that. Anyway, and the closure scope continues to contain all of its original variables. In other words, closure must be per scope implementation wise, and then an optional optimization trims down the scope only what was closed over. A similar outcome as per variable closure. Even as recent as few years ago, many JavaScript engines did not apply this optimization. It is possible your website may still run in such browsers, especially on older or lower end devices. That means it is possible that long-lived closures such as an event handler may be holding onto memory much longer than we will have assumed. And the fact that it is an optional optimization in the first place rather than a requiring of the specification means that we shouldn't just casually overassume its applicability. In case where variables hold a large value, like an object or an array, and that variable is present in a closure scope, if you don't need that value anymore and don't want that memory held, it is safer memory usage to manually discard the value rather than rely on closure optimization garbage collectors. Okay, so let's apply the fix to the early managed student grades. So anytime that it's because now closure is not only per variables, all right, that you use, but it's also per scope as well. Mm, mm, mm-hmm, mm-hmm. Kyle Simpson, Node.js environment. Um, mm, mm, mm. Mm, or node runtime. Maybe VS Code. No. Node Stack Bliss. All right. So for example, if I do something like this, assuming that this environment, which is run on WebAssembly, allows to do this, right? So if we save this and run that via node and say, hey, node, run this index.js. Wait, what? Exactly. Oh, hello, exactly. It's running this. Run node.js index in the terminal. But it's not calling this, right? Oh, because we are not. Okay, console log. Makes sense. Makes a lot of 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 sense. And there you go. Now, if we go to the terminal, right, and say no index.js, okay. You see? So in this environment that allow me to run eval, which is in Node, okay? Oh my God, oh my God, you shouldn't do this, but it allowed me to run is this piece of code where it say, hey, look at this. Now I can have access to this. Um, I can have access to these variables in that scope, even though I didn't declare them, even though that I didn't set explicitly in my function. But I access them at runtime. Oh crap! That's definitely not a good look. That's definitely not a good look. Mm-hmm. 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 So in case where a variables hold a large value, whether it is on as a parameter, usually it is safe for us to, or it is safe for memory usage to manually discard the value rather than rely on closure optimizations. In this case, well, we use now grades to do so. So for example, now if we want to modify that, right? And so after that, if we don't need that, value, we can say, hey, I want you just to, or just put it null, right? Put undefined, right? So release that memory undefined, and the same for this. So set this to undefined, right? So no matter which piece of data you pass here, is not a close over, do so. At least in this very contribute example. So we're not removing a student record from the closure scope that we cannot control. We're ensuring that if the student records remain in the closure scope, that a variable is no longer referencing the potential large of data. The array can be garbage collected. Again, in many cases, JavaScript might automatically optimize the programs to the same effect, but it's still a good habit to be careful and explicit. Make sure we don't keep any significant amount of device memory type any longer than necessary. As a matter of fact, we also technically don't need the function getGrade anymore after the .map getGrade call completes. If profiling our application show this was a critical area of excess memory use, we could possibly eke out a tiny bit of more memory by freeing up that reference so its value isn't tied up either. That's likely unnecessary in the stored example, but this is a general technique that keep in mind if you're optimizing the memory footprint of your application. The takeaway, it is important to know where closures appear in our programs and what variables are included, and we should manage these closures carefully. So not only holding on to what's minimal needed and not wasting memory. Remember, why we're doing this? Because grandmas, people that live on the strip, hobos, and computer science, all of them shares together the same thing. Be memory efficient, right? So you have limited space to carry out of your stuff, okay? And then you need to find ways, creative ways to actually see how to carry that, how to maintain that. The other is an alternative perspective. Reviewing a word definition for closure, the assertion is that functions are first class values that can be passed around the program just like any other variables. Okay, reviewing our working definition for closure, the assertion is that functions are first class values This first class is a value, and it's a value and has it is in it allowed uh, all of these patterns around it that can be paused around the program, just like any other value. So closure is the link association that connects the function to the scope variable outside of it itself, no matter where that function goes. To put it simple is this. So closure is the link association that connects the scope and the variables outside of the function, no matter where the function goes. So let's recall a code example for early in this chapter, again with relevant scope bubble colors annotated. So you got this outer global scope red, function adder, so you get adder number 1, function scope blue 2, right? And then you have now the function add 2, and the function scope which is green 2, right? And here you're gonna say, hey, because in the side of these functions, I am now have these identifiers where I can referencing inside of the function add2 and num2, and here I'm using is now a different reference or a different identifier that is not in this function. It leaves outside of this function. So JavaScript allow me to do that, all right? Num1 and +2, okay, which is the identifier from this scope, and then perform the operation, which is in our case, I just fix that initially. You say adder 10, and then I assign that to an identifier to hold that functionality here. This is the mind-bending stuff here of this functional programming, is that it allows you to not only hold the state of the application like primitive, but also functionality, bro, or girl, or sister. That's interesting. It allows you to now hold this functionality here, sister or bro. Add 42. So hey, I'm going to now hold this identifier with this specific functionality here. Adder 42. And then once I call this, you say, hey, add 10 to the number 15 and add 42 to 9 here. Why this is useful, right? Because now, again, functional programming allows us to define now this high order function or these functions where we can define is general purpose things or general purpose computations in this case. So adding two numbers or multiply or divide, but it's a computation that allows a genetic computations, and then we can now take specific use case and hold that into memory. So our current perspective suggests that whenever a function is passed and invoked, closure preserves a hidden link back to the original scope to facilitate the access to the closeover variables. Figure 4. Repeated here for convenience. Illustrate this notion. So yes. But there is another way of thinking about closures, and more precisely the nature of function being passed around that may help deepen the mental models. This alternative model de-emphasize, there is another way of thinking about closures, and more precisely the nature of function being passed around that may help deepen the mental models. This alternative model de-emphasize function as a first-class value and instead embrace how functions like a non-primitive value, are held by reference in JavaScript and assigned pass by reference copy and see Appendix 8 of the Get Started book for more information. So instead of thinking about the inner function instance of add2 moving to outer red one scope via the return and assignment, we can envision that function instance actually stay in the place in their own scope environment, of course with their scope change intact. So what gets sent to the red one scope is just a reference to the red one scope. Okay, what just sends to the red one scope is just a reference to the in-place function instance, rather than the function instance itself. Figure 5 depicts the inner function instance remaining in place, pointed to by the red one, add2 and add242 reference respectively. So now, exactly. Okay. So the thing, the perspective is that instead of thinking about inner function instance, we can envision the function instance actually just stay in the place in their own scope environment, of course with the scope change intact, and just passing that as a reference. So this alternative de-emphasize and instead embrace how functions, like all known primitive values, exactly, all functions like all non-primitive values are held by reference and assigned or passed by reference copy C. Respectively. So visualizing closure an alternative. So you say, hey, now is that scope that is going to hold that reference of that function, all right, which is the scope 2, right? It's going to hold now that reference, and it's going to assign or pass to the identifier, in this case the addler here, right? And when you invoke that, what you're doing is you just call that scope structure here. You're calling is that function here that have a live link to those variables at that moment. So as shown in figure 5, each call to adder still creates a new blue scope containing the num1 variable, as well as an instance of the green 3 add2 scope. But what's different from figure 4 is now this green instance remained in place, naturally nested inside of their blue scope instance. The add210 and add242 reference are moved to the red one, outer scope. Not the function instance themselves. When add210 15 is called and add2 is called, the add2 function instance still in place in the original blue 2, all right? Scope environment is invoked since the function instance never moved. Of course, it still has natural access to its scope change. Same with add242 and 9. Call nothing special here beyond lexical scope. So what then is closure if not magic that lets functions maintain a link to the original scope chain even if the function move around in other scope? In this alternative model, functions stay in the same place and keep accessing the original scope just like they always call. Closure instead describes the magic of keeping alive a function instance. Mm-hmm. Function instance. I'm keeping alive a function instance, along with its whole scope, environment, and change. For as long as there's at least one reference to that function instance floating around in any other part of the program. But this is the core of this. Closure describes the magic of holding is a function instance, along with its environment and scope change. Along with its uh, variables definitions and scope change. Variables are functions identifiers and a scope change for as long as there is at least one reference to that function instance floating around any other part of a program. That definition of closure is less observational and a bit less familiar sounding compared to the traditional academic perspective, but it is nonetheless still useful because the benefit is that we simplify explanation of closure to a straightforward combinations of reference, exactly, and scope, and in place functions instance. The previous model, figure 4, is not wrong about describing closures in JavaScript. It is just more conceptually inspired, an academic perspective on closure. By contrast, the alternative model, figure 5, could be described as a bit more implementation focused and how JavaScript actually works. Implementation focus here. Both perspective models are useful in understanding closure, but the reader might find one a little easier to hold than the another. Whichever you choose, the observable outcome in our programs are the same. So this is uh, this alternative perspective of closure is to say, hey, I'm going to hold that reference. I'm going to hold the, so closure is remembering, all right, or it's describing is the magic of keeping alive that function instance along with its environment and scope for as long as there is still a function's reference floating around in a program. No, okay. And this is more like a implementation wise on how JavaScript actually works rather than these academia concepts like this. And why is that? Because you can modify runtime conditions, which is you shouldn't do that. This alternative model for closure does affect whether we classify synchronous callback as an example of closure or not. More on this nuance in Appendix A. In Appendix A, implied scope, anonymous versus name functions, all right, and the hosting and functions variables, right, and variable hosting. And variable hosting. The case for var. Exactly, the case for var, let and cons. All right. So what's the deal with TDC? Okay, what's the deal with TDC? Are synchronous callbacks still closures? Mm. 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 Chapter 7 presents two different models for tackling closures. One of them is closure is a function, remember, it is outer variables even a function is passed around and invoked in other scope. And the other is a closure is a function instance, and it is a scope environment being preserved as long as you have reference. um, so closure is a function instance. uh, okay, closure is a function instance. Remember, it is variables even the function is passed around and invoked in other scope. And closure is a function instance in its environment being preserved in place. Exactly, it is a function instance and the scope environment being preserved while any reference to it is passed around and invoked in other scope. These two models are not widely diverged, but they do approach from a different perspective. And that different perspectives change what we identify as a closure. Don't get lost following this rabbit trail through closures and callback. Calling, calling back to calling back to what or where? Maybe synchronous callback isn't the best label. If functions don't move around, why would they need closures? Deferring over time is key to closure. So what is a callback? It is a function. So my definition of callback is, or what is true of the callback is a function that you pass down as a parameter to another function when that in that function will be executed at some point, right? uh, yeah. So what is a call? Okay, what is a callback? So a callback now a is a function that can be exactly is so a callback is a function that might be either it's a function that you pass as a parameter. It's a function that you pass as an argument to another function. That functions okay is a function that you pass as an argument to another. It's a function that you pass to a second functions as a parameter. uh, as an argument is a function that you pass to a second function as an argument, and that second function might even call that function synchronously or wait for something to be called to do so, right? This is why we have now synchronous or asynchronous callback. And let's get into this. Say, hey, let me ask Claw here a little bit. Hey, Claw. So it is safe to say that closure, it's safe to say that callbacks in JavaScript is a function that you pass down as an argument to a second function that to a second function where it may call right away or at some point in future. Okay, this is what we have now is synchronous and asynchronous callbacks, right? That's a good functionality definition. You capture the essence of the callback in JavaScript. To refine it slightly, a callback is a function passed as an argument to another function which that function can invoke either immediately or later. The key insight is that you're giving you're giving another function the ability to call your function when it needs to. Mm-hmm. Mm-hmm. So you have now the customization behavior reusable functions, handle asynchronous operations, response to events, and implemented inversion of control. The framework calls your code. One thing worth noting is while your definition is correct, in practice the term callback is in JavaScript is often used specifically for asynchronous callback, like Node.js in API, while synchronous one might just be called functions arguments or handle a function. But technically, they are callback. So, but technically, they are now functions that you're gonna pass as an argument to a second or to another function. That function might invoke immediately or at some or later or at some point in future. Mm-hmm. Mm-hmm. So this is the definition of a callback. Okay. It is generally accepted norm that saying callback is synonymous of with both and asynchronous and synchronous callback. I don't think I agree that this is a good idea, so I want to explain why I propose we move away from another term. Let's first consider an asynchronous callback, a function reference that will be invoked at some future later point. What does callback means in this case? It means that the current code has finished or paused, suspend itself, and that when that function in question is invoked later, execution is entering back into the suspend program, resuming it. Specifically, the point of re-entry is the code that was wrapped in the function reference. So in this case, this is a callback, all right, that at some point in future now it's going to call that function, put it at the call stack, and evaluate. Okay? Okay? So now the program is not suspend, it's just now evaluate that functionality, and it ends, and then now that function is going to now put at the call stack, in this case by the web by the web platform, and it's gonna put this callback at the call stack so it can execute it. In this context, calling back makes a lot of sense. The JavaScript engine is resuming or suspend programs by calling back at a specific location. Okay, so that's a callback. Okay, so a callback is asynchronous. So what about synchronous callback? So what about synchronous callback like this? Okay, so when you pass now the student ID, and here you're going to map that student ID, and then you're gonna pass now a function here, all right? So that this function will be immediately invoked by that function. Right? So should we refer to format ID label as a callback? Yes. You're passing now a function's reference to be executed at some point. So is the map utility really calling back into our program by invoking the function we provide? It will, by the time that we pass now, it will, by the time that we call that function, in this case they get labels, and we pass this. So there's nothing to call back into per se, because the program hasn't paused or exit. We are passing a function reference, which is this. We're passing as a function reference from one part of the program to another part of the program, and then it is immediately invoked. There is other established term that might match what we're doing here, passing in a function reference so that another part of the program can invoke. Passing, like dependency injection. So we're passing a function reference to another part of the program that can invoke in our behalf. You might think of this as a dependency injection or inversion control. Dependency inversion can be summarized as passing is a necessary part of functionality to another part of the program so that it can invoke them to complete its work. That's a decent description for the map called above, isn't it? The map utility knows the iterate over the list values, but it doesn't know what to do with those values. Wait, what? The map utility know to iterate over the list of values, but it doesn't know what to do with those values. That's why we pass now the format ID label function. We pass in the dependency. The inversion of control is pretty similar, related concept. Inversion of control means that instead of the current area of your program controlling what's happening, you hand off control of another part of the program. We wrap the logic for computing a label string in the function format ID label, and then hand that invocation control to the map utility. Notably, that Martin Fowler cites inversion of control as a difference between a framework and a library. With a library, your call it is function. With a framework, it calls your function. This is quite interesting because React is a lot of that. And when you use now a framework, for example, like Nodes or GraphQL or any clients or that, or any framework, specifically in a framework, is doing that. So with a library, you call your functions. With a framework, it calls your functions. In the context of our discussion, either dependency inversion or inversion of control could work as an alternative label for a synchronous callback. But I have a different suggestions. Let's refer to the function formerly known as synchronous callback and inter-invoke functions. Yes, exactly. I'm playing with immediately invoke function expressions and this inter-invoke functions. This kind of functions are inter-invoked, meaning another entity invokes them as opposed to invokes themselves immediately. What's the relationship between an asynchronous callback and a inter-invoke function? An asynchronous callback is inter-invoke that invoked asynchronously instead of synchronously. Synchronous closure. Now that we have labeled synchronous callback as inter-invoke functions, we can return to our main questions. Are inter-invoke functions an example of closure? The synchronous callback, okay? Obviously, if the IIF will have to reference variables from an outer scope for it have to any chance of being closure. The former ID label IIF from early does not refer any variables outside its own scope, so it is definitely not a closure. So what about the IFF? That does have an external reference. Is that closure? So for example, here the ID is not a closure, right? So you don't have any closure here. But if you for some reason now have this functionality and our referencing is the list, all right? The inner render label IIF reference list from the enclosing scope. Exactly. So it is an IIF inter-invoke function that could have closure. But here's where the definition model we choose for closures matter. If render labels is a function that get passed somewhere else, and that function is then invoked, then yes, render label is exercising a closure. because closure is what preserves it is access to the original scope change, and it is environment. But if an alternative conceptual model of chapter 7 render label stay in the place and only render label stay in the place and only a reference to it is passed to for each. Is there any foreclosure to preserve the scope change of render label while it is executed synchronously right inside of its own scope? No, that's just normal lexical scope. To understand why consider this alternative form of print labels, just a normal function called it in its own scope, right? That's not really a closure. Okay. These two versions of print labels are essentially the same. So aka here the latter one is definitely not an example of closures, at least not in a useful or observable sense. It is just lexical scope. The formal version with for each calling or function referring is essentially the same thing. It's not a closure, but rather than a plain old lexical scope function call. Defer to closure. By the way, chapter 7 briefly mentioned partially application on curring, which do rely on closure. And this is an interesting scenario where manual curring can be used. When you do this, list and render label, you call these functions down here, and this functions now is returning as another function, aka you have now a function invocation. That function invocation has now several identifiers: create label, this list, and this list that doesn't live inside of that scope environment, but it does on the scope change. So when you call that, now here render label is a closure. The inner functions create label, which we assign to render label. It is closed over list. So closure is definitely being utilized. Closures allow us to remember list for later while we defer execution of the actual label creation logic from the renderer 2. Call to the subsequent for each invocation of the create label. Immediately inter-invoke function that may only be a brief moment here, but any amount of time could pass a closure bridge from call to call. That was a lot. That'll be all for this video. Take care. Bye bye.